One of the aspects of engineering that a lot of students don't like to deal with is when you have to solve equations and formulas to come up with answers to problems that exist in the real world. One of these is the properties of solids, which is assignment 509. That's for both in class and virtual. So I want to give you a little head start here, a little guideline on how this might work for you. So this assignment is actually in the 509 properties of solids. This handout PDF or Word document. I'm going to go ahead and turn my actual camera on here so you can see uh, some work. I'll kind of sketch some work out for you here using the dock camera, and also show you where you would find your formulas and things like that that you need to do this work with. Okay. So if you actually look at your formula sheet, that's also electronically available in Project Lead the Way, you have your solid geometry. We just got through doing a paper on plane geometry earlier with area and perimeter, and now we're looking at solid geometry. So primarily, if you need to find the volume or you need to find the surface area, you've got all those formulas here. And then if you look on the next table or a few tables down on the next page, on table 9, you will see a formula for weight. It's volume times density, right? So those formulas are the primary ones we're going to be applying here in solving what we call the um, properties of solids on the little handout that was available to you here through the actual document, through the assignment. So again, if we open this up and look at it here, you actually have this document available to you. Okay, so I'm going to pull that up here on the bigger version of it. And if you look down through here, to do this first question, what's the volume, that's coming off the formula sheet, surface area, formula sheet, weight, formula sheet. And then it gets into some basic logical questions like, if you know the surface area, how much cleaning solution will you need? That's pretty easy. If you know the weight of what you have, you can figure the shipping cost by multiplying by the dollars per pound. Now F and G takes a little bit of a thought, but basically what they're doing is they're modifying the cylinder that's forming this counterweight, so it's going to get longer or shorter or wider or narrower, and you're going to modify the cylinder, but you're still going to be using the volume formula of pi r squared h to solve both of these. It's just a modification of the size of the cylinder. Likely also when you get to number 2, it's a board. And so you're going to find the volume of a rectangular prism. You have that formula available to you. The surface area, the weight, again, with the density formula. And again, some practical questions like if you know the surface area and you put 2 coats of paint, how much paint would be required? If you know the weight, how much would it cost to ship this many boards? And F requires a little thought in the fact they're changing the size of the board on you. Okay, so 1 and 2 is pretty straightforward. You just come right off the formula sheet with those. If you have questions, give me a call. Now, when you get to number 3, it requires a little extra thought. They're asking you this question, A, if you set this glass jar in water and it sets upright without tipping over, how far will the jar sink into the water? Now, that seems like a pretty difficult question, and it basically is, because we have to go through 5 steps in order to answer question 3A. And they lead you through that in the next 5 questions. They help you answer this question, how far will it sink? Again, they're giving you this information up here. They're telling you how thick the glass is, what the inside radius is, what the outside height is, and then they're giving you the density of glass and the density of water. But beware, these densities are in cubic feet. Our measurements are in inches. So we're going to have to change cubic feet to cubic inches by dividing by 1728, which is 12 cubed. So just be aware you're going to have to change these densities. So let's look here at number 1. Like, what's the volume of the glass shell? Now I want to show you over here on the actual document camera what we're talking about here. So we have actually we have a glass, an outer part of the glass here, right? And then you actually have the inner part of the glass. If you actually look at it, cut it away, slice the glass away, they're telling you the outside height of this glass is 6 inches, but you notice the inside height is not going to be 6 inches because even though you're starting from the same location, you've got this glass wall in here. And it said this glass wall is 3/16 of an inch thick. So that has to be taken into account anytime you're doing these calculations. So that means the sidewall is also 3/16 thick. And if you take 3/16 and you turn it into a decimal, it's 0.1875 inches. So it's a little bit easier to actually turn it into decimals, right? So if I want to know the height, think of this as a cylinder inside a cylinder, right? So you've got an outside cylinder and an inside cylinder, and we're gonna find the volume of both, and we're going to subtract, and what's left over will be the glass itself, right? So the inside cylinder, this height here will be 6 inches minus the thickness of the glass because you can't get through the glass down here. So it's going to be 6 minus 0.1875. So your inside height, the inside height, I'll put HI for inside height, is going to be 5.8125 inches. Okay. So make sure you're using that for your inside height when you do the inside cylinder. Now, in the problem, they told us that the radius here, the radius of the inside cylinder is 3 inches. Well, the same is true if we want to know the radius of the outside cylinder, then we've got to add the thickness of the glass to it because the glass adds thickness, so it adds radius. So the radius of the outside is 3 plus 0.1875, and so that means it's 3.1875 inches. So when you go to use the volume formula, and by the way, the volume formula is pi r squared h, right? Volume, that's the volume formula of a cylinder. If you look at the cylinder here with a radius and a height, so that we're going to be applying that several times. Both the outside, we're going to calculate the volume of the outside cylinder, and we're going to subtract the volume of the inside cylinder. So if you think of a cylinder within a cylinder here, right? That's how we're going to find out how much glass we have. So you will go through and you will do the volume of the outside cylinder is what? Pi times r outer radius squared times outer height. And then the volume of the inside cylinder is pi times the radius of the inner radius times the inner height. And then when you do outer volume minus inner volume, you'll have the volume of the glass, right? So that'll sort of answer problem number I for you, that first question that you see here back on the trying to answer the question, what is the volume of the glass shell? So that one requires the most work. You got to get the volume outer minus volume inner. Now, the weight of the jar, we go to the density formula. And when you go to the density formula, it is weight equals volume times density. Okay? And we usually show density as the Greek letter rho, like this. So weight equals volume times density. And so it back in the problem, remember, they told us the density of glass. So if you look up here in the original problem, it said the density of glass is 165 pounds per cubic foot. Okay. So remember, we're dealing in inches. So if the density of glass, I'll put a G there for glass, is 165 pounds per cubic foot, if you have a 1 foot by 1 foot by 1 foot cube, and you break that into inches, there's 12 inches in a foot, right? So the equivalent of 1 cubic foot is 12 times 12 times 12, which is 1,728 cubic inches in a cubic foot. So we have to divide this number by 1,728 in order to get a number of density in pounds per cubic inches. So just make sure you make that conversion before you use it. I'll leave you to calculate that. So then you're going to take the volume that you get up here, you're going to take the density that you get here, and when you multiply those two together, it gives you weight in pounds. Okay, so that answers the question 2, what is the weight of the jar in pounds? Now, a little trick question here is anytime you put a jar in water, it displaces its weight in water. So if the weight of the jar is, say, 5 pounds, then the weight of the water is 5 pounds. So the answer to 3 is the same as the answer to 2 based on the buoyancy principle. So that's an easy question. Just say, same weight as the jar. And then it says, how much volume of water does the jar displace, right? So now we're going to still use the density formula. So you're going to still use the density formula here that we had earlier, okay? But now we're applying, now that we will know the weight of the water, we will be able to calculate the volume of water that is displaced, right? So if we use this same formula that weight is volume of the water times the density of water, we already will have calculated the weight of the water. That's answer 3, like 3 eyes, right? And then we will already know the density of water that was given to us back in the actual problem here. The density of water is 62.5 pounds per cubic foot. So the density of water is 62.5 pounds per cubic foot. Again, we have to divide by 1728, and you're going to get a density in pounds per cubic inch. So now you take your weight from problem 3, you take this density here that you calculate, and you solve for volume of water. Because the volume of water is going to be more than the volume of the glass because water is less dense, okay? And then so if you go and the last question here, so the volume of water will answer number 4, and to get question 5, how far will the empty jar sink? Once you know the volume of water, you can plug it into the cylinder formula power squared H, because remember, you're actually taking out a plug of water that's in the shape of a cylinder, and you're already going to know the outside radius here. You're going to go back and you're going to actually use, so you're going to use the volume formula pi r squared H, and you're already going to know the volume of the water from solving this one. You're going to know the outside radius, which you calculated earlier is 3.1875, because that's how much water is being removed. And from that, you're going to solve for H, and that will be how deep the jar is floating in the water. So you end up with something like this, where the jar is actually floating partway in the water, and this little H here will give you that. So if you have any more trouble with this, be sure to ask me. The next little part of this for number 3 is to add honey to the jar and see what happens. So good luck on it, and just let me know if you have any more questions.